So basically now we need to discuss about the load balancing type. Last time we done the static load balancing. Now today we need to discuss about the load balancing type is which one, dear? The dynamic. Okay. Basically in static load balancing, we do the manually thing. Yes or no? If you're getting any changes in your server side, in your algorithm, so manually you need to do some changes. But in dynamic, what is the meaning of dynamic load balancing? So in this load balancing, basically device distribute the data traffic as same method. We can write down manually enable. Whenever network engineer use load balancing. So always configure on pull. Okay. Pull always support single load balancing. Which one load balancing, dear? Single load balancing only. One more thing. In this load balancing, F5 device distribute traffic across LAN side servers. But last time equally distribute. I think you know last time equally distribute. Now the load balancer will be distribute your data traffic across the LAN side servers on the basis of Pradeep, Rohan. Which one basis? On the basis of your load balancing algorithms. Which one? Load balancing algorithms. This algorithms check resources and availability and connection limits. Which one information verify? The connection limits. Now, one more thing. We can check also performance of your device. You can write down one more thing. Performance. Which type performance your server right now doing? Performance you can also check. Clear? You can check also hardware information. Which one? Hardware information. One more thing. If any changes occur, then load balancing algorithm automatic change. So in static load balancing, this thing will be happen. Pradeep, Rohan. In a static load balancing, we are getting this kind of scenarios. Any idea?
No, sir.
No. One more thing. With the help of dynamic load balancing, network engineer utilize all resources. Okay, all resources and data traffic distribute on the basis of layers information. Which one information, dear? Layers. Sometimes we are also checking the layers with the help of load balancing. So how many types load balancing available? So I think you already remember we are getting the first load balancing is least connection. Which one, dear? Which one algorithm? Least connection. Least connection means whenever we are using the protocols, TCP, UDP protocol. So we are initialize the sessions now with the help of port numbers. Yes or no? So in this load balancing, what is the meaning of least connection? This load balancing FI device check on LAN side servers how many active connections, how many active connections on server. So FI device will check in least connection. If getting higher connection active, clear? If getting higher connection active, then receive this server lowest connection request. Which one, dear? If you are getting a higher connection active on your server, so getting lower connection request on your servers, clear? If getting a lower connection on your servers, how many, dear? Pradeep, Rohan, lower connection active, then receive higher or lower? Any idea? Higher or lower? Anyone know? Pradeep, Rohan. Then we are receive higher or lower? We are receive higher connection request on server. So I think last time we create design, I think you remember, we are getting some clients. Hold on. This one is my client connected with my ISP, and this ISP connected with my FI device connected with switch, and switch connected with some of my servers. Clear? F5 switch, server 1, server 2, server 3. Clear? This one is 1.1, this one is 1.2, and this one is 20.254, 30.254, and this one is my 20.10. Hello, 20.20, 20.30. Pradeep, Rohan, clear?
Yeah.
So ये 30.254 20.254 अपना FI का इंटरफेस का IP है क्या?
Yes, this one is interface IP. This one interface available on your LAN side. This one interface available on your WAN side. Clear?
Okay,
Now,
30
one more
dot.
thing.
सर
Yes.
पूरा सॉरी बट आप पूरा IP लिखेंगे थोड़ा कंफ्यूज हो रहा हूँ.
192.168.30.24 network we are
Okay,
using on public facing.
public. Okay,
192.168.20.24 we are using LAN side. Okay. Now, so in this case, whenever this client trying to send the connection request on your servers, for which type of connection request? For example, this server providing right now web services. Which one? Web service. So we have web service means we are using HTTP, HTTPS, this kind of service. So this client say, I want to access your websites. So basically from this client, if I'm receiving the multiple connections request, we are getting the connection request, and this connection request received by which one device? FI box. FI device check on your LAN sites available servers. How many active connection available on your LAN site server? How many active connection on your server? So on the basis of your active connections, so verify how many connection requests you can receive. Okay, how many connection requests you can possible to receive. Same thing. I think last time we discussed this same design. For example, this one is your design. Last time we discussed, I think, a ratio concept. Everyone know the ratio scenario? Pradeep, Rohan, ratio scenario. Last time we discussed, na? We set the ratio to get the multiple connections, more connections. So same thing in list connection. For example, if someone define on my server 1, the ratio is a 2. How many ratio? The server 1 having the ratio number is 2, and server 2 having the ratio number is a 5, and server 3 having the ratio number is how many? 8. So in this case, why we define this kind of a ratio? Because this one is I3, this one is I5, and this one is which one device here? I7. In this case, whenever this client say, brother, I am sending the multiple connection request. How many? Multiple connection requests. So how to get this servers? How to get this servers? Basically, this F5 device receive your request. F5 device check virtual server, then virtual server to pull, and then pull to node. Inside pull, we are getting services plus we are getting the load balancing mechanism. Load balancing mechanism is least connection. So least connection means first connection received by which one server? Server 1. Second connection received by server 2. Third connection received by the server 3. But how many connection we are sending? For example, 7. So in this case, fourth number, server 1. Fifth number, server 2. Sixth number, server 3. So seventh number connection received by which one server? Seventh number. Seventh number connection received by server 1, server 2,
server 2.
server 2, basically. Okay. Why this ratio decide? Why this ratio? Basically, we are not set the ratio manually. We are not set the ratio manually. This ratio set by F5 device automatically. Which one, dear? Automatically. And one more thing, remember, higher ratio receive more connections. Which one, dear? Higher ratio receive more connection. Least ratio receive lowest you can say, or you can say lower ratio. We are not saying a least, we can say the lower ratio receive least connection. So in this case, which server receive the most connection? Server 1, server 2, or server 3? Which server receiving the more connections? Why? And why we use? Basically, server 3 having the i7 processor can do the quick response. Yes or no? That is the reason. F5 device, the ratio of server 3 is how many? 8. Server 2, 5. Server 1 is 2. So in this case, if your client sending the multiple connection request, so F5 device verify your servers, how many connections. So first time, if you don't have connection, so no worry. First, F5 device provide all connection equally, okay? Equally distribute. And after receiving the response, then F5 device decide which server getting the quick response time, server 3. And server 3 can possible to receive the multiple connections, yes or no? So in this case, server 3 will get the higher ratio, okay? Pradeep, Rohan, this thing is clear? Now, one more thing. In least connection, we are getting a 2 types of algorithm. We are getting, I think last time we also discussed least connection node, and second is least connection member. So anyone know what is the difference in between both algorithm, node and member? Why we use node and member algorithm? Node means total. Node means total from all services. From all services, connection check. And least means specific service connection check. So for example, server 1, server 2, server 3. How many servers we are getting? Pradeep, Rohan? 2 servers or 3. So basically we are getting the web service. We are getting FTP service. For example, for web service, server 1 having 2. For FTP we are getting 4. For server 2, 5, and this one is 3. For server 3, 8, and this one is 2. So basically, if you are using the node concept, node means how many total ratio on server 1 after FTP plus web? How many total ratio? 6 connections. On server 2, 8, and server 3, 10. If someone's sending the 11 connection request, how many? 11. So which one server first receives? Server 1, then server 2, then server 3. Then 4, 5, 6, 7, 8, 9, 10, 11. We can get easily if you are sending 19 connections. So that case 12, 30, 40, 50. Then 16, 17, 18. And 19 number connection will be received by which person? Server 1, server 2, or server 3? Which one?
2.
Verify.
Server 2.
Server 2, because server 1 is getting full connections now. So now 19 number will be received by server 2 because 8 number. 1, 2, 3, 4, 5, 6. Active connection is already open now. But server 2, 1, 2, 3, 4, 5, 6. Clear? So in this case. Done? Pradeep, Rohan, this thing is clear? This one is also available, na 7. Now. So any doubt for least connection? Least connection means, for example, HTTP service, HTTPS, FTP. So this algorithm we use. In this case, if someone asking least connection means F5 device check which layer information? Anyone know which layer information? Layer 4. Because on layer 4 we are using the protocols, and protocol depend on your services. Okay, protocol depends on your services. Now one more load balancing is available. After least connection, we are getting the second load balancing is fastest. Which one load balancing? The fastest. This load balancing in use in production network. Least connection we are not using, but fastest we are using in production network. Okay, why? For example, in this load balancing, F5 device. Check layer 7. Anyone know layer 7 means which layer? Layer 7 means which layer? Layer 7 means presentation,
Application.
application, service, which
Application.
Whenever network engineer deploy on F5 device, whenever network engineer map application server, then you can use this algorithm, okay, for load balancing. But right now we are using any application, dear?
No.
No. So in this load balancing, we are not using the application, we are using service, dear. So in this load balancing, profile must be configured. Which one feature, dear? Profile. Profile must be configured. Then you can use. Then possible to use. Okay. If you are not configured, possible to use. If not configure, then fall back. Then fall back to least connection algorithm. Which one algorithm, dear? Fall back to least connection algorithm. So whenever we are trying to using the fastest load balancing, so device must be map application servers. Okay, this thing is clear. Any doubt? Now one more thing. One more load balancing is available. Right now we are not using. If you are using, so same process. Check the layer 7 connection. More connections means receive higher request. Okay. Now second is done. Now third is observed. Which one load balancing? Pradeep, Rohan? Observed. Observed load balancing we are using in production network. Why? Basically in this load balancing, F5 device check a combination. Which one? F5 device check combination. Which combination? Which combination? We need to check how many least connection available. How many check? Least connection available. Then we check fastest metric. We check fastest metric. And then we check one more thing. We check the performance time. How many information we need to check, Pradeep? Least connection, information, fastest metric, and performance time. How to get this information? Go to CMD, and it's a example. If I am doing a ping 8.8.8.8. So can you please verify, Pradeep, Rohan? Wait. Can you please verify, Pradeep, Rohan? How many packets sent, dear? 4. How many receive? 1. Lost is how many? 3. And what is the my minimum time? 40 milliseconds. Maximum time 40 milliseconds. Average time 40. No worry. We again retry. For example, if I am doing ping 4.4. So we are getting, wait. Can you hear me? Hello, Pradeep, Rohan. I'm audible? Hello?
हाँ सर.
Yes,
Okay.
yes, yeah, we can hear.
Okay, wait. So now verify the minimum time, maximum time, average time. So after this time, we can get the metric. Okay, this metric we can calculate from my average time. Average time means minimum, maximum. Okay, performance time means CPU utilization. How many CPU utilize in your LAN side servers? So this least connection we can easily check. Fastest metric automatically calculate from backend process. Performance time you can get from your response time. Okay. Now this combination must be checked by FI device. No need to mention this combination anywhere. Only enable observe, and observe automatically calculate this combination outputs. Okay, automatically calculate the outputs. So for example, if someone says, sir, how to know? So basically this one is your design. Last time we are using. In this design, how many server we are using? Can you please verify how many servers we are using? How many servers? We are using
3.
3. Server 1 say, brother, I am having i3 processor, 4 GB RAM. How many? 4 GB RAM with 250 GB with 250 GB storage. Okay. And server 2 say, I am a i5 device, 8 GB RAM with 500 GB storage. Okay. i7 is I server 3 and 16 GB RAM we are using, and 1 terabyte is my storage. Now, in this case, basically this client say, I want to access your servers. Client send multiple requests on ISP receive and forward on FI device. FI device check. This first time request distribute all servers and calculate. Server 1 say, I will send back the response, this request response in how many? 5 milliseconds. How many? 5 milliseconds. Server 2 say, I am sending the reply is how many? 4 milliseconds. Server 3 say, I am sending the 2 milliseconds. So which one server having the fastest processing? Anyone know? Which server?
Server 3.
Server. Now again the client, multiple clients sending the multiple requests, then ISP forward F5 receive and forward on which server first? This case FI device automatically set the ratio again, automatically set the ratio on each server, server 1, server 2 and server 3. Now server 1 say, I'm getting the ratio is how many? How many ratio? 4. Server 2 say, I'm getting the ratio number is 3. Server 2 say 3. Server 3 say, I'm getting the ratio is 5. How to get this ratio? Basically, multiple client request, multiple. So this site client sending multiple requests, servers receive automatically request from F5 device, and F5 say, I'm providing the 4 connection on server 1. Server 2, I'm providing 3 connection. Server 3, I'm providing 6 connection. So 4 connection request, reply time is 5 millisecond. 3 connection request, 4 milliseconds. 6 connection request is how many milliseconds? 2 milliseconds. So which server response time is quick? Which server response time is quick and fastest perform? Server 3. On the basis of this response, server 1 get the ratio is how many? Server 1 say my ratio is 3. Server 2 say my ratio is 2. And server 3 say my ratio is how many, dear? How many ratio? 5? No. In this case, basically server 3, why get the ratio is 5? Because server 3 can capable to do multiple connection within a second. That is the reason. If in this load balancing, higher connection, more prefer. So if you are getting a higher ratio, so connection means you can remove this connection word and say higher ratio, more prefer. So which server having the higher ratio? Anyone know? Which server? Anyone know? Verify and observe. Server 1, server 2 or server 3? Which server having a higher ratio? Pradeep, Rohan, verify. Pradeep, Rohan, verify. Which server having the higher ratio? Server
3.
1, server 2 or server 3? 5 number. This one is the ratio. Now, after observe, some issue we are getting in observe. Basically, this FI device not capable to check my device's CPU utilization and which server is right now trending. Yes or no? Trending means which server getting the more connection. So in this case, observe, we are not using. We are using next algorithm. It's named predictive. Which one algorithm, dear?
Predictive.
Predictive.
Okay.
Predictive is more prefer in real time. Okay, we are using more. Why? Basically, in this load balancing, F5 device check again. F5 device check again conditions. So last time we are using some conditions. So same condition we are using? No. Basically, we are using first. Which one? Device check least connection. Okay, then device check the fastest metric. Which one, dear? Fastest metric. Then check device trending information. Trending server information. And then also check one more thing. Which one, dear? Which one informations? Resources. How many CPU utilized? How many bandwidth? Clear? How many buffer memory? What is the response time? Clear? So this information checked by which one algorithm, dear? Predictive. So predictive is more prefer over than this algorithm. Predictive is more prefer over than which one algorithm? Observe. That is the reason, because we check least connection metric, we check trending server, we check resources as well. So right now, last time we create again connection request. So same thing we need to do again in this design. For example, now server 1 say I'm having the i3 processor. Clear? Now server 2 say I'm having i7 processor, I'm having i5. This one is 2 GB, this one is 8 GB, this one is 4 GB. Clear? Any doubt, Pradeep, Rohan? Now, in this case, now, client sending the multiple connection request on my F5 device. Then F5 device distribute on each server first time. Now, for example, server 1 say I'm getting the 3 connection and my response time is how many seconds? How many seconds, dear? 5 milliseconds. Server 3 say I'm received the 5 connection and my response time is 8 milliseconds. Server 2 say I'm receiving the 6 connection and my response time is 4 milliseconds. So which server having the best resources, best performance right now? Which server trending in right now my production network? Can you please verify, dear? Which server trending?
Server
1.
2.
Server 2. So this F5 device again automatically set the ratio. Which one? Ratio. Server 1 get the ratio is 2. Server 2 get the ratio is 5. Server 3 get the ratio number is 3. So which server having the higher ratio, dear? Which server? Server 1, server 2. In this case, if someone say how to check the resources in predictive, so we are using some monitor. Monitor will use to send a request message to get the reply. In this monitor, we check the availability, we check the devices is up or down. We can check the device utilization also, CPU utilizations, okay? And how many response time we can calculate with the algorithm. This algorithm working in background, okay? Now, the 5th number load balancing name is dynamic ratio. Which one? 5th number, the dynamic ratio. So why we use dynamic ratio? In this load balancing, FI device check each server performance. Which one information, dear? Each device performance. Okay. And automatically set a ratio. Automatically set a ratio for each server. In this load balancing, FI device use monitors to get information about LAN side servers. Okay. So mostly cases we are using which one algorithm? Observed or dynamic ratio. Okay. Pradeep, Rohan, this thing is clear? Hello, can you hear me? Now. So for load balancing lab, you need to install this application in your laptop if you want to perform. Hold on, I will show you. This application name is Git Bash. Which one? Which one application? Which one, dear? Pradeep, Rohan, Git Bash. Okay. This Git Bash application will provide a load balancing task. Basically, with the help of this application, we can generate multiple requests. We can generate, dear, multiple requests. Okay. So this application for load balancing lab must be installed in your laptops. Can you hear me? Pradeep, Rohan, this thing is
Yes,
clear?
yes.
Okay, this application git bash. After installing this application, you can get this type of window. Hold on, I will show you this one. Okay, so on this window, we write down some commands to generate multiple connection requests. Okay, so before doing a load balancing lab must be done activation of your F5, must be done node pull virtual server, must be done availability or network configuration. Okay. Any doubt? Okay. Last time I think I already shared the F5 software folder. Last time I already shared, na? So in F5 folder, I think this software is available. F5. 5. Okay. This one. This one. Pradeep, Rohan, I think I already shared na, this folder for lab software.
Yes, yes, yeah.
So you can get the Git Bash application inside this folder. Okay. You need to download and install in your laptop. Next session, we do the lab side. Lab. Okay. Next session. Okay.
Sure. Lab for this load balancing, right? Action?
Yes. Next session, we do the lab.
Sure.
Any issue? Any doubt?
No, sir.
Okay, just go through both videos. If you get any kind of issue, so you can ping me directly. Okay.
Okay, sir.
All right. Sure.
Bye bye. Take your time. Go through this video, brother. Okay.
Yes, sir. Sure.